Okay, so a little bit more explanation on reciprocal graphs. I've done here the graph for y equals 5 over x, just to point out the reason it's a reciprocal graph is when you look at the equation, is because you've got an x on the bottom of the fraction. So as soon as you've got that, you know it's a reciprocal graph. So I've got a table of values here, so I've got the negative values here for x and the positive ones here, and I've worked them out by doing 5 divided by the x value. So 5 divided by negative 4 is negative 1.25, 5 divided by negative 3 is negative 1.6 recurring, I've rounded it here. 5 divided by negative 2 is negative 2.5, etc, etc. Now, you'll notice here, when we get to this one, 5 divided by 0, I've just got a line here. You can't divide by 0. If I get a calculator and we try it, you'll just get a maths error. 5 divided by 0 equals maths error. You can't do it. It's not infinity. Some people like to think that if you divide by 0 you get infinity, and I understand where that comes from, but that's not true. It's just undefined. It doesn't have a value, so we can't plot that point at x equals 0. And then the positive values, 5 divided by 0.1 is 50, etc. Now you'll notice, and this is a pattern that's repeated in the book as well in the questions that you'll do, that close to particular values there's more of them, and this is just to kind of show the jump that occurs. So when you plot these, so negative 4 is negative 1.25, the y value, and negative 3 is negative 1.67, etc., and negative 2 is negative 2.5, etc, etc. Now I haven't been able to plot these, so at negative 0.1, so just in here somewhere, the y value should be minus 50, but that's just going to go way off my scale. It would be way off the page. Similarly, for positive 0.1, 5 divided by 0.1 is 50, way off the scale, it's not going to fit on. So plotted your points, draw lines through, and you get this kind of characteristic shape. And just a few things to point out on this. So first of all, you get these asymptotes, as they've called. Let me just write that word. So an asymptote is a line that the curve gets really close to, but it never quite touches it. So if we think about it down here, this curve gets really close to this line, but it never touches it. So if you can see it a little bit here. It's getting closer here when x is 4. 5 divided by 4 is 1.25. If we were to think about x is 10, 5 divided by 10, so over here somewhere, is y is 0.5, so smaller value. And if you were to go even to x is 100, 5 divided by 100 is 0.05. So the y value is really small, but it's still positive, so the curve still isn't touching the x-axis, and it never will do. So it just gets really close. Similar sort of thing happening here, but you're dividing by a negative value, so your y value, as you go this way, becomes really small, but negative. Okay, so that's this asymptote. You've also got an asymptote here. This one's a bit harder to get your head around. You've seen it a little bit. If we divide by really small positive values, as you've seen here, you end up with a really large value for y. So 5 divided by 0.1 is 50. Now if you were to go even smaller, 5 divided by 0.01 is 500. So when you get really close there, you get a massive y value. So way up there. But it never touches this axis, because actually, remember, when x is 0, so at that point on the y-axis, there is no y value that you can plot for that. It's undefined. So it goes shooting up here. And then in the same way, when you've got really small negative values of x, like we had here, you get really large negative values of y. Because a positive divided by a negative is a negative, but when you're dividing by a really small decimal, you get a really large number. So that's what happens. So you go down here, and then there's this massive jump, and it starts up here, and then comes back around again. So that's the kind of characteristic shape of a reciprocal graph. You get these two bits with a big jump in between them. Just show you one more. So this is from the graph y equals 2 over x minus 3. Now just to say a little bit about the table of values, so I've got a table of values here again. Now you'll notice I've got a lot more values of x around 3. That's because that's the kind of interesting bit where it does this big jump. And that is in turn because around 3 that's where this denominator gets really, really small. So you end up with these whopping big values of y. So plotted the x values here, and then just to help in terms of calculation, I've also worked out x minus 3. So for instance, when x is minus 10, x minus 3 is going to be minus 13. And then that helps you to work out 2 over x minus 3, because you just do 2 divided by negative 13, which turns out to be, when it's rounded, negative 0.2. Just look at another one. When x is 1, let's say x minus 3 is minus 2. Okay, so 1 minus 3 is minus 2, and then we're going to do 2 divided by x minus 3. Minus 3 was x minus 3 was minus 2. So we're going to do 2 divided by minus 2, which is minus 1. So that's where these values come from. Just to say, you may not work those out. You may feel like you don't need to work those out. It doesn't help you. You might just feel you go straight from the x values to the final y value here. The reason I've set it out like this is just to mirror how it sets it out in the book. And then you're going to plot these x values against these y values, and you'll notice a very similar sort of pattern. So you get these asymptotes, and you get a big jump in the middle. Just to point out to you this way of setting things out in the book. Reciprocal graphs, there they are. You can read this stuff, it's kind of similar to what I've just been saying. And then the tables of values. These grey bits in the middle are really just to help you work it out. So when you're working out this one, they've suggested, first of all, work out 1 over x. So you're going to do 1 over minus 5 in there, 1 over minus 4 in there, etc., etc. And then plus 3, that's just coming from the formula. It's plus 3 for every single value. And then to work out your final, your y value, you're going to do that plus that. So in this case, minus 0.33 plus 3 is 2.67. In this one, minus 2 plus 3 is 1. And so then you plot those x values against these, what are effectively y values, down the bottom, and then you draw your curve. Okay, hopefully that makes it a bit clearer.